Hi everyone, my name's McKay, and I'm a second-year graduate student at the University of Guam Marine Lab. My research focuses on using coral genetics to determine species boundaries. However, for the past couple of months, I've been working on a side experiment called CBASS. CBASS stands for Coral Bleaching Automated Stress System, and it's a setup that was recently designed by a team of scientists to help speed up coral research. It's a variation on typical long-term heat stress experiments that are used to estimate how resilient different coral species are to increased ocean temperatures. An increase in ocean temperatures usually causes corals to bleach. And CBASS experiments are cool because instead of heating up corals for multiple weeks to test their resilience, you only need to heat them up for a day. Even cooler, research has shown that both experiments yield the same results. It is especially useful for places like Guam that don't have access to high-tech aquarium facilities for research purposes. Recently, we performed a CBASS experiment on 8 different species of staghorn Acropora corals. Staghorn corals are often less resilient to bleaching events, and because of that, they experienced extreme mortality around Guam in the past decade. Thankfully, a restoration team was formed to help repopulate staghorn populations around the island. However, there's still a lot of things we don't understand about these 8 different staghorn species. So to improve restoration efforts, researchers are studying different aspects of these corals, such as how heat resilient they are. This can help restoration practitioners decide where to outplant these corals around the island and which corals might be better in certain locations. For the CBASS experiment, we went out and collected coral fragments from the PD Coral Nursery. We then took those fragments and put 1 coral nubbin from each fragment into our 4 different tanks. These tanks were controlled to have the same lighting and water flow. However, they were heated to 4 different temperatures. For our experiment, we heated the corals to 29, 35, 38, and 41 degrees Celsius. After 6 hours of heating, all the tanks are cooled back down to 29 degrees. Once the tanks are cool, the lights are turned off so the corals can adjust to complete darkness. Dark-adapted corals are then measured using a PAM fluorometer. This device shoots a beam of light at the coral and reads its returning fluorescence. The output can be used to estimate how bleached the coral is. We performed this experiment over 3 nights and tested a total of 60 coral fragments. In addition to looking at how bleached each coral was, we also took samples to use for genetic analysis and flow cytometry. Genetic analysis and flow cytometry samples were preserved in salt buffers or in liquid nitrogen. These techniques will be used to determine whether the bleaching was caused by the coral itself or the algae cells within the coral. This is a super cool experiment to perform because it requires far fewer resources than long-term heat stress experiments. If you're looking for a way to estimate how different corals respond to bleaching, look into CBASS testing and see if it might be a good fit for your research. Stay tuned for more videos about the result of our experiment, and a huge thank you to everyone who helped with this experiment, everyone who carried it out, and all the scientists who designed the system.